In previous video, we have discussed ninth standard chapter 1 matter in our surroundings. The previous concept we have discussed already is states of matter. Then shall we now step into next concept, that is, can matter changes its state?
Yes, absolutely. That's a great transition into the next topic. So, we've learnt about the different states of matter. Now, let's explore how they can actually change from one state to another. What comes to your mind when you think about matter changing states?
You can tell that one.
Sure thing. So, matter can change states when it absorbs or releases heat. Think about what happens to an ice cube if you leave it on the counter. It melts, right? That's because it's absorbing heat from the surroundings and changing from a solid to a liquid. Similarly, if you boil water, it turns into vapor. That's it absorbing heat and changing to a gas. Does that make sense?
Yes.
Great. So that brings us to concepts like melting point and boiling point, the specific temperatures at which matter changes states. We can discuss those in more detail, or we could move on to other factors that can affect matter state, like pressure. What would you prefer?
First one we should prefer, and then we move on to the next concept.
All right, let's dive into melting point and boiling point then. So basically, the melting point is the temperature at which a solid becomes a liquid, and the boiling point is the temperature at which a liquid becomes a gas at standard atmospheric pressure, of course. Would you like to know more about these specific points or something else related to them?
Yes, more specific points for this.
Sure. So, for melting point, it's the temperature at which the particles of a solid gain enough energy to overcome the strong attractive forces holding them in place, allowing them to flow like a liquid. For boiling point, it's the temperature at which the vapor pressure of a liquid equals the atmospheric pressure, enabling it to boil and escape as a gas. Does that provide enough detail?
Yes.
All right. So now that we understand melting point and boiling point, would you like to explore how these states change in our daily lives or delve into how pressure affects them?
Then both we can discuss. First, how the changes in our daily life occurs, and then we can move on to the pressure affect them.
Sounds like a plan. So we already talked about melting and boiling, which are great examples of state changes in our daily lives. Can you think of any other instances where you've seen matter change states around you?
Tell me that one.
Another common example is freezing. When you put water in the freezer, it turns into ice. That's the liquid becoming a solid because it's losing heat. Or have you ever seen condensation on a cold glass? That's the water vapor in the air cooling down and turning back into liquid water. So these are a couple of more examples for you. Shall we move on to pressure now?
Yes.
Alright, let's talk about pressure and its effect on the states of matter. You know how when you go deep underwater, the pressure increases, or when you fly in an aeroplane, the air pressure decreases? These changes in pressure can also cause matter to change states. For example, increasing pressure can turn a gas into a liquid, and decreasing pressure can make a liquid become a gas. Would you like to know more about how pressure works with specific states?
Yes.
Sure thing. So, think of a pressure cooker. It cooks food faster because the sealed container traps heat and increases the pressure inside. This raises the boiling point of water, so the water gets hotter before it turns to steam, cooking the food faster. On the flip side, if you decrease the pressure enough, a liquid can turn into a gas even below its normal boiling point. Does that help clarify?
Yes.
Great. So we've covered how temperature and pressure can change the states of matter. Is there anything else about this topic you'd like to explore? Or should we move on to the next concept?
Okay, shall we discuss on interconversion of the three states of matter?
Absolutely. Interconversion of the three states of matter is such a fundamental concept. Basically, it's when matter changes from one state to another, like from solid to liquid or liquid to gas and so on. We've already touched upon some of these processes like melting and boiling, but we can delve into the others as well, like sublimation and deposition. Would you like to start with a specific process?
Okay, we can start with the evaporation.
Great choice. So, evaporation is when a liquid turns into a gas without boiling. It happens generally at temperatures below its boiling point. You see this all the time, right? Like when you leave water in a dish, it gradually disappears. That's the water evaporating. Would you like to know more about how it works?
Yes.
So evaporation is crucial in the water cycle, right? Where water evaporates from bodies of water, forms clouds, and then falls as rain. It's also essential in many industrial processes, like the production of salt or evaporated milk. And on a more personal level, it's why clothes dry after washing. Are any of these examples interesting to you for further discussion?
Yes.
Okay, let's talk about that. Artificial snow is made by creating a fine mist of water droplets that freeze in cold air. This involves evaporation of some water, which helps cool the remaining droplets through evaporative cooling. Then these supercooled droplets crystallize into snowflakes. It's a fascinating blend of physics and chemistry. Would you like to know more about how this cooling process works?
Okay, thank you. This one is helpful to 9th standard students. We will discuss next concepts in next video. Thank you.
You are most welcome. I am happy to help 9th standard students understand these concepts. Yes, let's discuss the remaining concepts in the next video. Is there anything specific you would like to prepare for the next class?
Okay, that's enough.
Wonderful. I look forward to our next video discussion then. Have a great day ahead.